Good afternoon. I'm Mike Wooding from Remote Sensing Applications Consultants, and I'm reporting on a project to investigate how Sentinel-1 radar data can be used to improve the checks on farmer subsidy claims, which need to be carried out as part of the Rural Payments Agency work in England and also by other UK administrations. This has been carried out by Remote Sensing Applications Consultants working with Airbus, Defence and Space, and government partner Rural Payments Agency. RSAC is a small company which specialises in agricultural applications and has 20 years' experience now of undertaking subsidy control work with the Rural Payments Agency and Welsh Government. I'm going to start with a little bit of background on CAP compliance checks. It's a requirement of EU CAP funding that national administrations maintain accurate parcel maps of the land being claimed for payment, and also that detailed checks are performed on 5% of the applications every year. Satellite data have been used for many years now to undertake these 5% checks within a number of distributed control zones. Single date, very high resolution images, generally with a resolution of about 0.5 of a metre, are required for undertaking many of the detailed checks. But in addition to this, there have been some new requirements that have come in 2015 related to crop diversification rules, which require most farmers to grow several different crop types and satisfy rules in terms of the percentages of cropped areas. And this has increased the complexity of the compliance checks because multi-temporal images are required and necessary for discriminating a large range of different crop types. The provision of optical satellite data is organised through the European Commission, but in the UK, Cloud continues to limit the acquisition of timely imagery to fulfil all the requirements. For instance, in 2015, there was poor image availability that meant that RPA had to organise an expensive alternative ground data collection programme to partially perform the required checks. So the project that I'm going to talk about here has focused on using all-weather imaging radar data from Sentinel-1 as a more reliable means of verifying the crop types required for these checks. The Copernicus Sentinel satellites that we're using are really real game changers for those of us working in agricultural applications because they offer a significantly better frequency of coverage than was possible previously, combined with this free and open data policy. The first Sentinel satellite, Sentinel-1A, is a radar satellite, and this has now been operational for 20 months. And Sentinel-1B, a similar satellite, has now been launched successfully. And these provide routine coverage of the whole of the UK on a 12-day repeat orbit. The images covering 250 kilometres with a 10-metre resolution. Radar is sensitive to temporal changes in the roughness and structural properties of crops, so making crop discrimination possible. The Sentinel programme also includes Sentinel-2, the optical satellite that was launched started operations in November 2015, and this is another instrument that is very important in combining with the radar data for crop mapping purposes. I just want to give you some initial illustration of some of the potential, just start by illustrating something of the potential of radar. This is a 3-date multi-temporal composite of images obtained in May, June and July. And on this we can see that the crop AC66 is winter wheat, and that field is consistently dark here with a low backscatter on all these 3 dates. Whereas the AC63 coded crops here, which are winter barley, are green. They're having much higher backscatter in the June date than the wheat. And oilseed rape crops are consistently lighter here. These codes are the RPA codes that are used by the farmers. Now, when we Now, rather than just using these sort of 3-date composites, we're able to really exploit the full potential of Sentinel-1 backscatter measurements in 2 polarizations taken every 12 days. And here we see an example backscatter temporal profile for a typical field of wheat. And here we can see that we're having through this period, we're seeing a gradual increase from May up until to just before harvest. And we're seeing a peak associated with the ripening of the crop. So this is a sort of key feature of this crop. And if we look at winter barley, for instance, we can see a markedly sharper peak here, which again is related to the ear development at this time. Here we're looking at a date of the 28th of June. If we look at spring barley, for instance, we can see that this peak is delayed by approximately a month because of the later ripening of that particular crop. So we're getting distinctive profiles here for different crop types. So the methods that we've been developing over the last few years are enabling us to identify and differentiate between different crop types using these temporal differences in backscatter. And in our Land Cover Plus project with the Centre of Ecology and Hydrology, we've used more than 300 Sentinel-1 images to produce an annual crop map of the whole of the UK based on Sentinel-1 data. This crop map is generated within the framework of the UK land cover map, and we've taken the parcels mapped as arable, here shown in brown, and parcels mapped as improved grassland. And we've essentially coloured these up and classified them with different crop types in 8 different classes. These are the main arable crops, plus grass, and a category called other that includes mainly the vegetable crops. So the sort of mapping accuracies that we're getting, sorry about that, the mapping accuracies that we're getting with this map are ranging from about 97% for oilseed rape down to about 80% for some of the row crops such as potatoes and sugar beet. And this product is starting to be used for a lot of catchment modelling work and for catchment sensitive farming work. I've got button problems here, I keep pressing the wrong button. Right. So the annual crop map that we're producing here is available in October every year and has some value for checking on crop types declared by farmers. But however, the CAP control focuses more on verifying declared crop types, and this can be achieved with much more accuracy when we actually are provided with the crop that's supposedly in the field. So we need to now look more closely at the crop diversification rules that apply to farmers, and we can see that when farmers have more than 10 hectares of arable land, they have to have at least 2 different crop types, and they have to have there are some requirements in terms of areas of those crop types as well. And as soon as they get to over 30 hectares, they have to have 3 different crop types with certain requirements in terms of area. There are some special requirements related to farmers that have a lot of temporary grass and fallow land. So these are the regulations, and there are some of the issues related to this are that there are a very large number of eligible crop types, and it's unrealistic for all of these to be positively identified using remote sensing techniques. Also, a lot of farmers declare 2 or more crops in a field, and the parcels have to be mapped as well as verifying the crop type. So this complicates the job a little bit. Sentinel-1 data, based on our previous experiences, are only really suitable for verifying some of these crop types, but they are the most commonly grown arable crops, and they are approximately 70% of all the crops that are declared. Optical satellite data may also be used to extend this analysis depending upon image availability. So we've essentially developed a two-stage approach for verifying crops. Stage one is an automated Sentinel-1 based approach where we use our time series data and we identify and verify the main arable crops. And this can be completed in a fairly automated way for more than 70% of the declared arable crops. But then we have a second approach that is able to be used, which involves manual image interpretation using the particularly available optical images that are available for that particular area. And I think an important point to make is that stage two is actually unnecessary in order to complete crop diversification checks on many applications. So just simply by verifying 70% of the parcels, we can actually see that the farm has achieved the regulation. So this shows the sort of crop types declared by the farmer. We have two control zones that we're looking at here called Sure and Watt. And you can see the numbers of the particular fields in this batch that we're looking at. You can see there are very large numbers of winter wheat fields, oilseed rape, barley, spring barley, beet, sugar beet, field beans, maize. All of these we can classify, verify using our automated Sentinel-1 approach. We're unable to use that on these other crop types. So I'm just going to show you some of the results, one example of the results from our checking, and this was the largest batch that we looked at. We looked at farms in two control zones. We digitised part fields and carried out our two-step process. And in one of these zones, we looked at 840 parcels, and we identified 22 parcels with crop type discrepancies. And in this area, we had 8 parcels with crop type discrepancies. So this is the sort of numbers of discrepancies that we're getting. We actually think the farmers aren't doing this on purpose, I don't think. This is basically just mistakes. And I don't think it's actually helped by the actual coding that RPA have given to the fields. It's not very clear. I think if it had been, they'd been coded as WW for winter wheat and MA for maize, I think we would have fewer discrepancies here, to be honest. So that's not a good thing. So if we look at some of the results, unfortunately there were not many ground data fields for us to look at in these areas. But of the 23 parcels with ground truth data, the crop types matched for 20 parcels. There were 3 cases not matching, but in 2 of these cases, the main part of the field was digitised, and we were looking at an alternative small part where there was ground data. In another case, a field of spring barley was found to be grass by us, but actually, when we looked at it in more detail, we actually found that this was actually a ground data error. So if we look at this particular picture, we can see this is a typical field of spring barley with green bare soil field here and red infrared vegetation here, whereas the ground data field has almost the opposite on that. It has green vegetation here, which was grass, and cut grass here. So in this case, the one major error that we made was actually a ground data field rather than something due to our inefficiency. If we look at the other zone, we can see that 11 parcels out of the 14 matched. We had 3 cases here. 2 of these cases also were complicated by there being small bits in the parcels that we hadn't properly identified. But we had another case here of identifying a field where the ground data was wrong. So one of the conclusions we come to is that Sentinel data is more accurate than ground data collection. So that's a useful conclusion. So as part of this project, Airbus have also been involved in developing their Sentinel-1 stack processor to improve capacities for processing the large number of images which are needed. And there's also been work carried out on SAR coherence processing and evaluating how coherence products can potentially improve the crop discrimination. So summary results of the project, I think the project has focused, it's done other things, but it's mainly addressed the main crop diversification objective that I've been talking about by developing and demonstrating a new methodology for verifying crop types based on Sentinel-1 data. Our pre-processed stacks of Sentinel-1 data have provided an input to an automated process and that has enabled us to verify these most commonly grown crops. RPA has evaluated these results against ground data and some other false data supplied to test the system. And this has generally demonstrated these high accuracy levels. So crop diversification checks can be completed for the majority of applications using just this Sentinel-1 automated procedure. And on top of that, we would add some manual interpretation using whatever optical images happen to be available for the particular sites to complete the checks on some other applications. So in terms of future development, both our SAC and Airbus are committed to continuing this development of the demonstrated service capabilities to provide a reliable, very cost-effective operational service for CAP compliance, both potentially for RPA and for other UK national administrations. The provision of these checks obviously need to fit in with other contracted activities that these organisations have, and that's quite a big issue. But we also, as well as looking at RPA, we're also looking to try and further these developments with the Scottish, the Welsh, and DARD in Northern Ireland to incorporate this sort of procedure in their checking. We think we've made quite big steps in improving the production efficiencies through the use of industrially hosted processing capabilities because we are processing large numbers, hundreds of Sentinel-1 images and integrating this with a lot of vector data sets to do this sort of work. And in the future, we're also interested in demonstrating additional enhancements to the CAP compliance checks by incorporating some Sentinel-2 optical data. Thank you.
Unless there's any questions, finally, oh, sorry, there is a question. Sorry, right. Hold on to you for a little bit longer.
Hello, Chris Jacobs, Government Office for Science. Just interested in what you think the advantages are of using satellites versus using drones for this sort of approach, both under sort of current regulations for drones, but also if restrictions are sort of eased in the future.
Well, in our approach, we've mapped 2.5 million fields. We have a drone, and generally you can go out and image half a dozen fields in a day, possibly. So it would take, first thing to say, it would take a long while to use drones to classify all the crop types in the UK. In terms of, well, some of you may have been at a DEFRA conference recently, a few months back, about talking about the use of drones in CAP compliance work. To be honest, I think it's a bit of a red herring because for the CAP compliance work, most of the work is required in actually sort of maintaining the accurate boundaries of parcels and determining some of the conditions. And really, a drone is a tool for more deep, we use it for sort of precision agriculture work and things like that, counting plants. It's a very different sort of tool has very different applications than control work. We've been working in control work and remote sensing for 20 years, and I've never dreamed of using a drone for control work. But drones have applications. I'm not saying drones don't have applications, but for large area compliance mapping, where the main objective is to determine that the farmer is declaring the right areas of his fields and he's cutting out the right bits of ineligible feature, then I don't think one would get any benefits from flying a drone and spending so much time looking in one field in detail.
Thank you, Mike.
Yeah.